Hello everybody. In this video, we are going to be dealing with the concept of a function. Now, when we're talking about functions, we are trying to say that with every input, there should be an output. So if I were to look at it in terms of mathematics, then we would understand that we would look at functions as on a Cartesian plane, okay? But before we go to the Cartesian plane, let's quickly understand the stuff that you may have learned within primary school. Just the way of functions and how they actually work. Alright, we are now back in primary school, guys. I know you're very excited for this, so let's get right into it. So when we are dealing with inputs, right? Let's say, for example, we need to see our function box first. It is trademarked because I own this function box, okay? So what do we do, right? In primary school, you guys didn't deal with, okay, maybe grade 7 you did, but before that, you didn't really deal with variables or letters. However, you did deal with maybe like a box, right? Like a little gap, and then maybe it says multiplied by 2, right? And this is actually the input box, okay? So the inputs get stored into this block over here, and then it undergoes the multiplication by 2, and then it produces an output, okay? So basically if I take the value of, let's say, 3, and I put it into this box, right, the function box, the 3 will actually go inside of this box, it will do the multiplication, then it goes all the way out, and then bam, just like that, it produces 3 times 2, which is 6, okay? And then if we look at the other one, let's say another value, let's say maybe 12, then it goes into the box, then 12 times 2, it produces an output which will be 24. And if we say maybe 102, it also goes once again in the box, and it does its function stuff. My thing is wonky. Anyway, it goes in the box, 102, multiplied by 2, we'll get 204. Okay, simple, hey? Now, let's actually translate this into Cartesian plane form. However, we're not going to actually draw a Cartesian plane. We are going to be dealing with x, y, and our new introduction. Well, not really new, but for some of you, I suppose. But if you're grade 10, then f. Let's do this. Okay, here we go. So we have a whole section for inputs where we have x values, okay? And then an output for f of x values. And this is essentially what we mean by our y values in Cartesian plane, obviously. This would be our y outputs, okay? So just keep that in mind. But for now, we're going to call this f of x, okay? But don't stress about the f of x. You'll see how that actually works within the function box. Trademarked by me, by the way. So, anyway, so let's do this all in orange, okay? So let's say, for example, I have a function box. And what is the function? Well, think about it, right? This stores our value, that is the input, and then it just shifts the input values to wherever the blank spaces are. It forms whatever output needs to go out, okay? It does its function, and then it outputs the value. So let's think about it like this, right? If I were to take the number 2, right? I'm going to input number 2. Also, the arrow should be facing the other way. So today it has a misdirection. So don't mind that, by the way. So if I place 2 into this function, wherever I see the blank space, I'm going to just place the 2 right there, okay? So even if there was more than one blank space, I will still put the 2 there, okay? So now you can see it's 2 to the power of 2, which is 4. 4 plus 1, which is 5. So it gives an output of 5. What if I take the value of 7? That means the whole thing is going to change inside, and my whole thing is going to disappear for some reason. Alright, there we go. That's like the hardest thing ever. So f of 7 is going to be what is in our function box, because now we're placing 7 inside. Then it's going to place that 7 on the inside over here. It's going to do the function. It's going to be 7 to the power of 2, which is 49. 49 plus 1, which is 50. There we go. And that is our output. Okay. And now for the last value, let's just take maybe 10. And then now the number is going to change So which means we're having f of 10, right, where the output or the input goes. 10 squared, which is equal to 100 plus 1, which is 101. You see, it's as simple as that. Now, what if we had to look at it in a mathematical perspective? Okay, so let's bring Cartesian planes into this. Okay, so here we are on the Cartesian plane, right? So I need you to stick with me for this one. Think about it like this. Before we get into actually like dealing with numbers right now, well, I guess we're going to kind of have numbers. Let's think about it this way. Let's say that this is a function, okay? You see this red line over here, this red arrow that goes up to down, or sorry, down to up, I suppose, if you're looking at it the other way. We're going to call this f of x, okay? And that is how we usually represent functions. Usually people will write down just f as it is, but for this one, I'm going to be calling it just f of x, okay? Because this is what our function's expression is going to be. So usually it would be best to just label it f, but for this one, it's going to be called f of x. So if I look at the horizontal axis, this is what we call the independent axis, meaning it doesn't matter what we're going to choose from here. This is where our inputs lie, the x-axis. That's what we call it. It's the x-axis. So it would be axis. And then here it's the y-axis. Okay. The y-axis is the dependent variable which produces outputs. So the y-axis depends on the x-axis's inputs, basically. Okay. And how does those actually correlate to each other? Well, if I take any point, let's say that this is point A, okay, and then I just lead it all the way up to the function. Well, notice that once I reach this point of the function, there should be some type of output as well simultaneously after it touches the function. This function has its own type of expression, maybe. Usually it holds some expression where the a value, the input, undergoes the function and it gets manipulated into an output. But in this case, we call this f of a. Notice it's f of x, and because one of our inputs are a, that is where x is equal to a, in that case over here. And then our coordinate, we'll name it as the x value, which is a, and then the y value, which is f of a. Okay, cool. Now that we've dealt with that, let's understand what happens when we deal with actual equations. Okay, so here is the first example that we have here. If f of x is equal to x squared plus 1, then what would f of 3 and f of 8 be? Well, in this case, look here, right? Here's our function. This is what we call the function. If you remember, the f of x is our function. And you can see here, this is the process in which the input is manipulated to give us the output. Okay, so what would f of 3 and f of 8 be? So what did we say? We said that within this f, we are going to have, what is it? Our x value. You can see that if it was a case where maybe this was another variable, let's say z, or maybe it was y, then you would obviously notice that this was either z or y, the actual values over here. But in this case, this is an indication of the variable we are using, which is x. So you can see here that 3 must be replaced with x to get f of 3. So we'll just do that. So f of 3, right, notice that we replaced x with 3 on this side. And remember, in the function box, wherever the blanks were, that would be where the 3 would go. Meaning, wherever the x goes, or sorry, wherever the x is, the 3 will go there. Meaning, it'll just be 3 squared plus 1, right? We are just replacing x with the number that we want. Okay. And then from here, f of 3 will just be equal to 3 squared, which is 9, plus 1, which is 10. Now, that is our output. What about f of 8? Well, f of 8, it's the exact same process. Notice we're replacing 8 with x, and then wherever we see x in the other side, we will replace 8 with that. Therefore, it will be 8 squared plus 1. Therefore, f of 8 is just going to be 8 squared, where 8 squared is 64, plus 1, which is 65. There we go. That is how to deal with the functions in terms of f of x. Let's just do one more other example to see if we understand the whole point of the functions. Okay, so here's example number 2. So you would actually expect it to pay attention to the Cartesian. Remember what I said with the Cartesian plane, where the f of x, or the f of a that we found at the point A, then f of a would be the y value, meaning we would replace every other y within the equation, because usually they give us an equation in the form of y equals whatever. You'll see that the second point of the coordinates would usually have the y value, okay? And then the first part, which is the left-hand side, would have the x. So let's read the question. Given the coordinates 2y1, okay, and 11y2, if y is equal to 2x minus 3, find the values of y1 and y2. So let's think about it this way, right? Notice that the coordinates are usually in the form of x and y. Same with this one, x and y, unless otherwise stated. Usually if they give different coordinates. I mean, not coordinates, variables. So if this was z, then this over here would most likely be z, because y, that would be your inputs. So notice that your inputs go to the left side, and then the outputs would go on the right side. Okay. Anyway, let's find y1. So meaning our output, which would be y, would actually be y1, meaning we're going to replace y with y1. So here, the first step is to replace y with y1, and we're also going to replace x with 2 for the first one, obviously, okay? Meaning from here, we are going to have y1 is equal to 2 multiplied by 2. Remember, we're replacing the x value with 2 in this case over here. And then we're going to minus by 3. Therefore, y1 is just going to equal to what? 2 times 2, which is 4, minus 3, which is 1. So there we go. We found the first value, which is y1. What about the whole case of the other coordinate that gives us y2? Well, think about it this way. For the second coordinate, we have x equals to 11 and y equals y2 in this case here. So our input would be 11 and our output would be y2, meaning we're going to replace y with y2 in this case over here with the next coordinate, and then we're going to replace x with 11. Okay. Then what's going to happen is we are going to have y2 in place of y is equal to 2 multiplied by 11 minus 3. And then therefore y2 is just going to be equal to 2 times 11, which is 22, 22 minus 3, which is equal to 19. Okay, and there we go. We just found the value of y2. So usually that's how coordinates work, and that is how functions actually work. So the concept of functions is for every input, there should be an output. And in this case, we just applied the use of coordinates where we can just plug both of them at the same time. However, sometimes we still need to find out the output of some missing variable. And this is some introduction to the functions.